Hello, this is Charles Culp, owner of swtuts.com, and I'm here today to introduce to you the new SolidWorks 2014 tool, Style Spline. This tool is based on similar functionality that we already have with the spline tool, but I think you'll find that the Style Spline is much easier to use for many different types of curves. I think you might even find that you'll use this most of the time when you're creating splines. So let's go ahead and talk about what the tool is. First, let's add it to the toolbar here. You'll find it under Tools, Sketch Entities, Style Spline. Let's go ahead and add it to our toolbar first. I'm going to Customize, add it to my shortcut bar for sketches. We can find it under the Sketch Options and add Style Spline. Let's just go ahead and quickly show what it is. When creating style splines, they're created differently than regular splines. With a regular spline, if you want to create a curve, you create 3 points, and the curve follows through those 3 points. Actually create these control vertices instead of actually controlling the spline itself. The benefit of this is that they're much more easily controlled. You can easily add control geometry here. We can set constraints on those. By adding these constraints, we can add dimensions. And while the old spline tool is very difficult to dimension, this style spline is actually pretty easy. If we go ahead and fix the corner, we just need to add one more dimension here, and we now have a fully defined curve. Before, with the spline tool, if you adjusted the control handles and you wanted to add dimensions, you would have to go in and dimension the strength of each handle. So you'd have 8.3 inches, and I'm not quite sure what that means because it's the strength of the control handle, and as they adjust, they aren't really proper units. So that's a bit confusing. Down here, this all makes very clear sense. The line of this control, the distance between these two control vertices is exactly 8 inches, and that's more concrete. So that's kind of what they are. We can talk about the underlying math here. I have some corners here, and normally when you create a style spline, you're not going to actually constrain the control vertices with actual geometry. They're more for reference, but here we can show what it takes to create these. So here's a 2-degree style spline. Every degree of a style spline is for every line segment we see. So this is a 2-degree style spline, and we can see that kind of how the math works here. This is the same thing as the string art you might have made in 4th grade. The curve that naturally flows out is that same curve that you would see from that string art. We can add more degrees. We can even create more of an S shape. You can kind of see how that math works out. When you create style splines, these vertices do not actually form constraints. That's on purpose. We don't really want to constrain those to real geometry. Like I said, this is more just as a demo. So they will snap, like you saw, they snap to points, but they don't actually stay constrained, so we can go back in and tweak it later. Because we're not really interested in whether the control vertice perfectly snaps onto points. We're more interested in the curve itself. So that's just an easier tool so we can snap to things without them being constrained. We can also go in and adjust the curve degree through this dialog in the Property Manager. Once you add constraints, this ability disappears. This will gray out. But for now, we can go ahead and add those. As you can see, all it does is add more control vertices to up the degree of the curve. Let's go ahead and take a look at a practical application of this. This is a trestle table. We can take a look at this in 3D. And one of these legs has this nice arcing shape to it. Now, this is something that I designed in SolidWorks using the regular spline tool. And I had to use two splines to get there, one spline for the top half and another spline for the bottom half. That kept nice clean curvature. But let's say, for example, this is your reference and you're not exactly sure what. We're not going to use existing model geometry here. We're going to go ahead and try and recreate this as if it was from scratch. So let me press the space bar here and go back to a straight on right view. So I'm going to go ahead and create a style spline. I will cheat and we'll start exactly at this endpoint. I will not cheat anymore though. I won't snap it to tangency. I'm going to hold down the control key. And I'm going to try and eyeball it as if I was looking at, say, a sketch picture or something like that. I can go in here. Remember, we're not putting the points where the curves are. We're doing a control vertice around the parts. So I know I'm going to end up wanting to be directly vertical here, but I can kind of eyeball where this can end up being. Click again, and like I said, I will snap on my endpoints. So there's our curve. I can go in and tweak this a little bit, get it to line up. We can add constraints, right? So we know we want that to be vertical. We can get a really good approximation here. This is only a 3rd degree spline, and of course, in general, you want to keep the degrees as low as possible. Those create better curves. We can go ahead and look at this, show curvature, show what the curvature comb looks like. Nice and clean, so that's good. Okay, now I can go in, and if I know what angle I want, or I want to make an approximation, I can, that was an angle, try again. Go ahead and go to the top plane this time and make an angle. 52.75, sure. And if we dimension this length here, we can dimension this length here, and these are kind of ambiguous, but they're dimensionable, and they're very predictable when we modify them and give us much predictable results. If you've ever done it with splines, it's kind of crazy. So let's go ahead and hide this curvature combs. Take a look at that. So it looks very nice. I'm going to hide this for a second. Let's do this with a regular spline tool. Let's create a new sketch. So we're getting that point. And what we do, we come in here and say, okay, I'll eyeball it there, eyeball it here. We can snap to this endpoint. Okay, so that's not what I want. I can take this end one and we can make that vertical. Still not quite right. So one thing that some people will do is just add more points. It's not really the best way to do it. Okay, we can't cheat. I'm holding down control to make it not snap. And that's close. Now that wasn't even as close as that style spline was. You can see we're still not quite getting what we need here. So even this isn't really great. We can go ahead and tweak with it and get kind of close. The real problem here is when we look at the curvature combs. You can see that we have these sharp jumps in curvature. It just doesn't look like a nice smooth curve like the style spline was, which made a much more elegant curve. That'll be beneficial in the final product because it'll look smoother. Also, if we go ahead and make a spline in a more preferred way, create another sketch in the right plane here. Instead of adding more vertices, what we really want to do is just use these handles on the existing vertices. Try and even this out. So we can go ahead and move these, rotate these, and go here and try and move this one, and oh, it freaks out because it's so tight there, and we get the error, so I have to undo. I have to be really careful in here, and with the style spline I didn't have to be careful. It's much more calm and predictable. And this is close. Yeah, I can't really add dimensions to these, so I have to keep it all unconstrained. I can't constrain anything, because if I constrain part of it, then if I make changes later, part of it will change and part of it won't. So I normally keep my splines completely unrestrained except for the endpoints. And that's not necessarily the best way to do things, but it's better than constraining a few things and not others. So here we go, and let's take a look at this curvature. And this is a little bit better. We have less points, but it's still not nice and smooth like the style spline was. So for a curve like this, this is really a good use for the style spline. Another thing with style splines is when you're working with them and you need to do multiple style splines together, I'm going to go ahead and delete these constraints. Let's say we want to do this entire edge in one sketch. We can do this with two style splines. Obviously we get a very nice curve when we do one style spline for the top half, so I'm not going to try and do this all in one spline. That way I can constrain to this point here because we want it to meet here. I find that in general with style splines, if you have constraints, you should only add those to the end points of the style spline. You can constrain the spline itself to points, but with style splines it's better to avoid that. So let's go ahead and make this two separate style splines. Make this vertical coming down up here. Go to the end point. Okay. Make this kind of tangent here. Bring this down. That looks pretty good. You will see that we kind of curve in a little more here than what the existing table looks like, but I think that's okay, and aesthetically thinning down this area here isn't going to really hurt anything. So maybe the style spline actually gives us a better curve than what the old spline tool gave us before. That's kind of the way I looked at this here. Is the old curve actually had a sharp change in curvature right at this point, and we're really just cleaning that up because it forces us to, and that's good. So here's these two. Now there's a few commands here in the property manager. The curvature degree is locked down because we made these two control lines, constrain them vertically, so we can't just modify the curve degree here. We can show the curvature. I'm actually going to hide that. We don't need that for now. There's also this local edit checkbox, and that's what I wanted to talk about here. Right now, if I go in, I try and modify this point, I cannot move it right to left, because by moving it right to left, I would also be modifying this curve. And the local edit just basically locks down, so that when I'm modifying one curve, I can't modify the other curve in any way. And that's just a safety feature. If you've ever worked with multiple splines using the old spline tool. If you have two splines connected like this, you modify one and the other one can go around and do crazy things. So this is more of just a safety feature. So if we click on this and we get rid of the local edit, now when I move this control vertice, you can see it moves everything and I'm fully unconstrained like I should be, or would otherwise be expected. That is on by default when you create a spline, and I think that's beneficial. So just keep that in mind if you do need to edit them together. So what about closed splines and open splines with end constraints? We can take a look up here at this geometry I've made. Style splines are not necessarily meant for closed splines, but they can be used. I made this octagon here as a reference so we can kind of make a pretend circle. And again, I'm constraining to, or not constraining, but I'm snapping to existing geometry with vertices, which is not something we'd normally do in real practice, but just to demonstrate this, how this style spline works, I want to go ahead and do this. It will make a closed spline, and you can see at the endpoints, it does make it both tangent and curvature continuous by default. Not by, I don't even mean by default. You can't get around that. This will be a curvature continuous closed loop spline. We can go ahead and show the curvature on that so we can see what's going on. You can see that the curvature is the same. What that means for the control vertices is that these two lines, go ahead and hide this again, is that these two lines on either side have to be tangent to each other, and it doesn't show that as a constraint, but that is going on. If I snap these endpoints in, you can see that it turns that line black. So these two lines here are collinear, and that makes the style spline ends tangent to each other. They're also equal in length, which is what makes it curvature continuous through that endpoint. So if you have a closed loop style spline, you'll find that it always makes these two lines collinear and equal in length, which is a bit confusing because it's a constraint that doesn't show up. Just recognize that it's there. And we can actually fully constrain this by snapping all these points. Again, we wouldn't really be snapping the points on a real model. We would be dimensioning them in some fashion just to control the shape. There we have a black, fully constrained, closed spline. Most of the time, though, if we're going to create something like a style spline, we might be working with existing geometry and trying to create a curvature continuous path between them. So we can come up with the first one, make that tangent. We have to make at least, I think it's a 5th degree to do curvature continuous on both sides. 1, 2, 3, 4, 5, 6, 7. So this one's 7. That'll give us 2 additional control points in the middle to control the shape. Okay, so we can make this curvature, make that curvature. See, all of our control vertices line up in a line. That's creating that curvature control. And we can control these two here to adjust the shape. If we don't like one, we can just delete the point. That leaves us with one control point to move around. And we can move these of course they're collinear, but we can move those around to change the shape as well. So that's kind of how it works with existing line segments. Style splines also work really well with 3D sketches. Let's go ahead and take a look at this table down here again. Let's go ahead and create a 3D sketch. We'll just pick 2 random points along here. Oh, I did that wrong, of course. Pick a point, then we'll pick one out in space. Then I'll bring it back. The benefit here is 3D splines are quite difficult to work with, but style splines, because there's less direction control and more just controlling these vertices in space, we can add dimensions to this point in 3D space, and that makes a lot more sense to me. So we'll go to the top, right, and front. Okay, and it's still undefined because these two endpoints aren't coincident with the point in space. They're on lines. We can see that this point control vertice here is black. And so now if we want to control the shape, all we have to do is modify these numbers. And it moves very predictably in space. Also, what we can do is not use dimensions. But we can move with the triad. And this drag and drop in 3D or drag in 3D space and get nice even controls, and that's a good way of doing this as well. Of course, you can also hit spacebar, look at it from 2D directions, and do it that way as well. When you're looking at it from just a 2D direction, you only move in those two dimensions. So that's the style spline. Like I said, I think this is going to be my tool of choice for creating splines. I will probably only use the regular spline tool when I need to do significant changes in direction. So if I wanted to create a spline that looks like this, that's fairly easy to do with the spline tool. With the style spline tool, of course, we have to exaggerate everything. And we get nicer curves. But those sharp changes in curvature are just difficult to create and difficult to handle. In general, those are best avoided, so I probably won't be using this spline tool very often for those. But that's when it might be necessary. So I think this is a great enhancement for 2014. And I hope you are able to play around with it. And if you create smooth contoured shapes, then maybe this is going to be the tool for you. Thank you.